roles are relevant for when you're transforming regular sine graphs or regular cosine graphs to a transformed version of the graph. So first things first, when you look at this, you see sine right here in the middle. And then you see these two values in the front and behind right here, and behind. You know this 2 in front is representing some type of vertical change. And this behind here is representing some type of horizontal change. So on this case, you see right here, when you see this 2 right here, you know that there's a vertical stretch. And it's by factor 2. Okay? And now if you look back here, you see this, you know that it's a horizontal stretch by a factor of 3. Now, a factor of 3. Now, looking at it, it seems odd that you might look at it and automatically think it's a shrink because it's like a fraction. Well, horizontal stuff is like, it's kind of the inverse. So when it's like a factor like that, that's a stretch. And now also looking at this negative sign. When you see this negative value, this negative sign in front of a vertical value, then you know that there's going to be a reflection over the x-axis. Reflection over x. Okay. Now that we've gone over some rules, we can now try graphing a transformation from sine. Okay. Now, some people they like to graph the parent function of sine, which we went over earlier, the original function of sine, and then do the transformation, like do the different transformations, movements, and shrinks and stuff to it afterwards, and graphing it again. The way I like to do it, which I think is the easiest way, is the first thing is just find the period of this function by using a period formula. So, period formula. This formula is going to be 2 pi over horizontal factor. Now what this means is that you're going to have 2 pi over whatever is happening over here. Because as I earlier stated, when you see right here on the behind the sign, in these little parentheses, you know that's going to be some type of horizontal change. So whatever is in that is going to be a horizontal factor. And so what we're going to do, to find the period, p, we're going to do 2 pi over 1/3, because this x over 3 is essentially 1/3. And this is going to equal 6 pi. And so, now that you know the period of 6 pi, it makes things a lot easier. Because what you can go ahead and do here is put 6 pi right there, and put 3 pi right here. Because you know that the full length weight, you only have to graph one wavelength, it's going to be 6 pi, and this is going to be half of it. And since, because of our knowledge of sine, we know that there's going to be points on all the zeros, on zeros on all the holes. So it'll be right here, right here, right here. Let me do that in a different color. But and you also know that there's going to be points on the halves. And also, which I should have mentioned earlier, see this negative side, we're not ignoring it. What we're going to do first, we're going to graph it pretending as though it's not there, and then after we do the transformations from here to here, then we're just going to flip the graph over. I think that's the easiest way. So, now we have a point at the half, like I said before, it's going to be about here, say all the way up here because remember this part right here, there's 2. You can go ahead and just graph the 2 right here. This makes it easier. Graph the -2 right here because this 2 tells you the vertical change, aka it tells you what the amplitude is going to be. So it's going to be 2, and that's going to be -2. And then all to the top. So you put your point right there. As we know, sine goes up and then down to that loop, and we know that there's going to be a point. The point that's going to be at the 2 is going to be on the halves, which are here and here. Go ahead and put a point right here. And now this is basically like this function, but we forgot one thing. But we didn't do one thing, and that is the reflection. And now that we have basically the same thing, we're just gonna do that exact thing, but flip it over. And now, of course, the points on the zeros are gonna stay the same because they're on the x-axis. So now all we have to do is take this point, flip it over to -2, and take this point, flip it over to +2, and keep these points here the same. Nothing happens to them. And you can just graph it. And there you have on the purple line, the purple solid line, this transform graph of f(x) equals -2 sine x over 3. Now, for one final graph, transformation graph, let's try for cosine. And now we're going to do the same thing for here. Where you know the period formula is going to be 2 pi over horizontal factor. And now that since we know that, we can find the period, which is going to be P period equals 2 pi over the horizontal factor, which in this case is going to be 2x. Because see how I told you before, in front of it, vertical, behind it, is the horizontal chain. Here is 2. So it's going to be 2 pi over 2, which is just going to be pi. So the period of this is pi, and then you can see that's actually a shrink, a horizontal shrink. That's why I said before how you thought maybe it'd be opposite, that you see a non-fraction it'd be growth and fraction would be shrink, but it's not. You see how the period is actually smaller than 2 pi, the original period function. It's actually pi now, so it's shrinking horizontally, and that's why it's made like that, so where when it's a fraction, it's a growth, and when it's not, it's a shrink. So now this is pi, and it's going to be pi over 2, and we know since this is 5, this is the vertical change, the amplitude is going to be 5. So the max and min is going to be 5 and -5. And we know that originally the cosine graph starts at 1, but in this case it would be 5 because it's when the vertical change shape is 5. So we're going to start. There's going to be a point here at 5, and there's also going to be a point at pi, because you know from our knowledge of cosine, it's always going to be that V-like shape or U-like shape from up, down, up. And you know at the end where the period ends, it's going to be one up here. Then halfway between those, right here, there's also going to be a point at -5. See how these points right here? This is at -5, these are at 5. And now there's also going to